This video just covers how to do the transformations using the GeoGebra tool that I embedded a link to in your OneNote page. So when you click on the link, it should just look like this. The first thing that you need to do, if you remember, because we've used this before, is we need to label the angles, side lengths, and the area measurements. So if you click on More in those tools over in the left sidebar and go down to Measure, area is the one on the far right. You just click on area, click in the middle of the triangle, and there's your area. So record that in your data table. We also want the length of each side. So click on the distance or length tool and just carefully click in the middle of each side. You should get 3, 4, and 5 for this right triangle. You might remember that as one of our Pythagorean triples. We also want the angles, because what we're going to do is we're going to see when we dilate this shape, make it bigger and smaller, we're going to collect some data to see what happens to the side lengths, areas, and angles of the shapes. Instead of just making any assumptions, we'll collect some actual evidence. So when you're measuring areas, click on the measure angle tool, or sorry, when you're measuring angles, and just click on the two sides on either side of each of the vertices. So angle B is 53.1, angle A 36.9, and angle C, as you can tell, is a 90-degree angle. Once you've got all those measurements, remember on the left sidebar to go up and click on the Move tool, because if you click somewhere, it'll start making more points or doing things that you don't want it to do. So if you click on the Move tool, you can move the window around and things like that. You can also move your labels around. So if you have a label that's kind of in the way of some stuff, you can grab that label and you can move it. For example, that 90-degree angle, I could scoot over here so it's easier to see. So record all those in your data table, and the next thing you want to do is you want to dilate this shape. That's why this red point D is down here. That's our center of dilation for this exercise. We're just using the origin for all of these to keep things a little bit simpler so we can see what happens to the coordinates, the side lengths, angles, and areas of these shapes when you stretch them or shrink them using a scale factor. So to dilate this shape, on the left sidebar of tools, go down to transform, and you'll see there's a bunch of different transformations you can do. They should look kind of familiar. Feel free to mess with any of these if you want to. GeoGebra has some really cool tools in it for studying the effects of transformations on geometric shapes. But we want to do a dilation. So click on the Dilate from Point tool, and you'll see the instructions pop up down below. And I'm going to show how to do this to make a dilation. So click on Dilate from Point. It says Select Object, then Center Point, then Enter Factor. That's your scale factor. So first I'm going to click just on the middle of the shape, not any of the numbers or labels, just the middle of the shape. So now it's selected. Now I'm going to select the center of dilation, which is that red point D right at the origin. And then you're going to enter a scale factor of 2 for the first one. So enter 2, click OK. And there is your dilated shape. You might need to recenter it a little bit so you can see all of the parts of the shape. So remember, use that Move tool in the top left of your tools. Now, some of your measurements went along with it. So you'll notice you'll have your side lengths, 6, 8, and 10, another Pythagorean triple, but it didn't carry the angle measurement with it. So go back down to the Measure tool and click on Measure Angle. And same idea, click on the sides on either side of each vertex, and it will give you those angle measures. And notice they're all the same. So they are still 53.1, 36.9, and 90 degrees. We also want to measure the area to see what happens. Go back down to your Measure tools, select Area, click in the middle of the new triangle, and you have an area of 24. So make sure you record all those in your data table in OneNote, the side lengths, the angles, the area of the new shape. And now we want to do a dilation with a scale factor of 3 and with a scale factor of 0.5, or 1/2. So I found it's actually easier just to start with a clean slate. You can do your dilation with all of your measurements on this same page, and you can end up with all 4 triangles, but it ends up being a mess. It gets really hard to label those measurements and everything and to read those and see what numbers go with what triangle, stuff like that. So I actually would recommend hitting the reload button. And it gives you a fresh copy of the triangle. You don't need to label this one with those measurements again, because you already have the side lengths, angles, and area of the original triangle. And so to save yourself a little time, you don't need to do that again. So what we're going to do is go to the transformation first, do dilate from point, and this time we're going to do a scale factor of 3. So click on dilate from point, click on your shape, click on the red dot at the origin. This time enter a scale factor of 3. And now we just need to measure everything. We want to see what happens to the side lengths, angles, and area. On your data table, you might make a prediction. Based on what you saw the results were for a scale factor of 2, you can make a prediction first and then make your measurements and record that and see if your prediction was correct. If you are having any trouble with the tools, I know sometimes things glitch out. I'm just going to go over those so that if you are having a hard time collecting the data yourself, you can just get it from this video. So our area is 54. Our angles stayed the same, 53.1, 36.9, and 90. And then our side lengths. So 15, 9, and 12. So make sure you record all that data in your data table. And I'm going to reload the page one more time and dilate this with a scale factor of 0.5. And again, before actually doing this, it's always good to kind of exercise your understanding of what's happening and see if you can recognize the pattern that's happening with how a dilation affects the dimensions of these shapes. And then check your prediction using the animation. Okay, so again, you already have the dimensions of this, so go straight to dilating from a point down at the bottom. Select the shape, the red dot, scale factor of 0.5. So this time, it's this smaller triangle that's your new transformed shape. Remember, a dilation with a scale factor that's less than 1 makes the shape smaller. Now we want to measure the area, angles, and side lengths. Looks like our angles are staying the same, 53.1, 36.9, and 90. Oops, I did the wrong one. 36.9. 53.1 and 90. And now the area of the smaller triangle, 1.5, and the side lengths of the smaller triangle. It's like 2.5, 1.5, and 2. So record all that in your data table, and then respond to the prompts below about what you notice the effects of a dilation are on the coordinates, the XY coordinates, the side lengths, the area, and the angles of your shape.